In this session, I'll discuss the structure questions from topic momentum and collisions. The first, you will find MCQs. MCQs you will solve. I'll start with a structure question, that is from question 16 onward. The question 16, the photograph shows a jumping toy. The head is pushed down onto the base and compressing a spring. When released, the spring expands and the toy jumps into the air. So basically, when we compress, deform, elastic strain energy is there. When we release, that change to kinetic, and then the kinetic change to gravitational potential. A student investigated the toy. The student places the toy onto a balance to measure the force required to compress the spring. The force was 14 Newton. When the spring was fully compressed by 1.7 centimeter, when the toy was launched, it jumped to a height of 1.5 meters. Show that the maximum energy stored in the compressed spring is about 0.1 joules. So the energy stored, or elastic energy stored, that is given by a formula, that is half force into extension or compression. So half F into E or F into delta X. So half the force which we need to completely compress, that is equals to 14. And it is compressed to by 1.7 centimeter, but the extension or compression should always be in meter, the SI unit. So we divide by 100, which is equals to 0.017. So when we simplify, this will give us how much energy is stored, which is about 0.119 joules. So this is the amount of energy which is stored as elastic strain energy. The next part, initially the spring was fully compressed. As the toy was released, the head accelerates upward onto its own until the spring is uncompressed. The head then pulled the base upward and then moved together at the same speed. As you can see here, the head is actually pulling the base and they move together with the same speed. The student used the elastic potential energy or elastic strain energy stored in the spring to determine the maximum speed of the head, at what speed it will move. The student used the gravitational potential energy gained by the whole toy to determine the initial speed. Determine whether the toy obeys the law of conservation of momentum using the values of a speed calculated in this way. The mass of the head is 6.4. The mass of the whole toy is 7.2. That is in grams, and the maximum height which is jumped is equals to 1.5 meter. So first, using the conservation of energy, like we considered all the initial kinetic energy converted to elastic into potential energy. So we can say the kinetic energy, or EK, the kinetic energy is equals to gravitational potential energy, or E. The kinetic energy is equal to half mv square, and potential energy is equal to mgh. M will cancel with m. So it means half p square is equal to gh, or p square is equal to 2gh, or p is equal to under root 2gh. So under root 2gh, what we'll get the speed. So 2 gravity, which is 9.81, and the height which does move, as I mentioned here in the question, the maximum height is 1.5. So using the maximum height as 1.5, And this we are getting the speed of the head, and using the speed of the head, because they move together, head and the base will move together. So the height is equals to 1.5 meter. We substitute, we'll get the speed at which this head will move. So the speed at which this head will move, that will come out as 6.1 meter per second. That's the first thing. Now, we were using this speed, we want to show the momentum is also conserved. So the total initial momentum is equals to total final momentum. Or we'll use the conservation of momentum. The total momentum before collision should be equal to total momentum after the collision. So this 6.1 meter per second is the speed of the head. Now, what will be the speed of the whole toy? Like now, what is the because we want to show the momentum is conserved. So total momentum before as the spring is released, the head is moving, and then later the base is also moving. So the initial momentum is due to the head, and the final momentum is due to the whole toy. So using this mgh, we work out the speed at which the head is moving. Now the momentum of the head, momentum is a product of mass and velocity. So mass into velocity, the mass of the head, which is 6.4 gram, we will convert into kilogram, which is 0.0064, multiplied by speed at which the head is moving, 6.1. So the momentum of the head is 0.039. That is the total momentum before, like the starting momentum, because in the beginning, the head was moving, and then finally, the whole toy was moving. Now we'll calculate the speed at which the whole toy will move. So first, this whole gravitational potential energy. So first we'll find the gravitational potential energy of the toy, which is equals to mgh. So mass of the toy, that is 7.2 gram, which is 0.0072, multiplied by gravity 9.81, multiplied by height is 1.5. So this will give us the gravitational potential energy of the toy, which is 0.1066. After getting the gravitational potential energy, what is the initial speed at which the toy will move? So we'll say the potential kinetic energy is equal to potential energy, so which is 0.106, and kinetic energy is half mv square. It will be half the mass of the toy, which is 0.0072. The speed at which the toy move, we are finding that. So when we simplify the speed at which the toy, initial speed at which the toy will move, 5.42. So this will move at 5.42 meter per second. And initially this was only the head was moving with 6.1 meter per second. So when we calculate the initial momentum is a mass of the head, which was 0.0064 multiplied by speed. And the final momentum is a total, because the whole toy start to move. So the total mass of the toy is 0.0072 kilogram, and the speed at which it moves. So we multiply them to get the final momentum. So 0.0072 multiplied by speed at which the toy will move, 5.42. This will give us the final momentum. That is also 0.039 kilogram meter per second. So it shows that the total momentum before is equals to total momentum after. So it is obeying the law of conservation of momentum as well. Another question, the photograph shows an airplane which is powered by two engines. When the airplane is cruising, air enters the engine at the speed of 252 meter per second and it is ejected at a higher speed, which is providing the thrust for the airplane. The mass of the air ejected by one of the engine in 1 minute is 34,600 kilogram. The total thrust provided by the engine is equals to 138 kilonewton. Calculate the speed relative to airplane at which the air is ejected by the engine. So again, we will use the conservation of momentum. We can use the conservation of momentum, or we can also use that the change in momentum, rate of change in momentum is equals to force. Like as we know, we have the formula F equals ma. And acceleration is the change in velocity, so we can say v minus u over t. When we simplify, so F is equals to mv minus mu divided by d. This will give us the relation between the force and the change in momentum. Like rate of change in momentum is equals to applied force. So we have the formula, or if I take m common here, so F is equals to m, the change in velocity divided by time. So we have the force which is 138 kilonewton, so it is equals to 138,000. The mass of the air which entered, that is 34,600. So this is 34,600. Multiplied by, because this is the 34,600 is the amount of air which entered. As you can see, the total thrust by the engine, so it is for two engines. And for one engine, this much amount of air entered, 34,600. But because it's a two-engine aircraft, so it will be multiplied by 2. That's the total mass of the air which will enter the engine. Then the change in velocity divided by time, that is in 1 minute. So in 60 seconds, so time should always be in second. When we simplify this, 138,000 multiplied by 60 divided by 34,600 and divided by 2 as well. So this will give us how much the velocity changes, change in the velocity. So the difference in the velocity or the change in velocity will come out as 120 meter per second. So delta V, or the change in velocity, which is final velocity minus initial velocity. The speed at which the air entered the aircraft, the engine, the speed at which it entered, that was given 252. The initial. We need the final. And we calculated using this formula, we calculated the change is 120. So if the change is 120, the final we don't know, and initial is 252. This is subtracted, other side will be added. So 252 plus 120, that is 370. So when we calculate this speed, it will come out as 372 meter per second. So this is the speed at which the air is ejected from two engines. Another question related to momentum and energy. In UK, the maximum legal speed for a pellet fired from an air gun is 184 meter per second. The diagram shows a suspended block of a wood used in a school lab to determine the speed of the air gun pellet. So air gun fires the pellet, the pellet is stick to this wood and move together. The pellet is fired from air gun into a block of wood as shown, and the pellet stayed in the block of wood, and the block of wood and a pellet together they move. The maximum speed which is reached is about the maximum height reach is measured. In particular experiment, the maximum height is 6 centimeter, which is 0.06 meters. The mass is 0.93 gram, and the mass of the pellet and the wood together is 150. Show that the speed of the block of wood immediately after it's struck by a pellet is about 1. So we'll use a conservation of the energy, that because as this block move upward, it will have a potential energy. So before it will have a kinetic. So all of its kinetic energy converted into gravitational potential energy. So the potential energy is equals to kinetic energy. And the mass of the pellet and the wood, because they stick together, which is 150 gram. Remember, always use SI unit, so mass will be in kilogram, and height is given in centimeters, so it must be in meter. So EP, potential energy, and will be equal to kinetic energy, or the loss in kinetic is equal to gain in potential. Potential energy is mgh, and kinetic energy will be half mv square. M will cancel with m. So gh is equal to half v square. This will be the 2gh in a root will be equal to v. So the height which is moved, that is equal to 0.6 centimeter, which is 0.06, and gravity is that when we substitute these values, we'll get the initial speed at which the wood and the pellet will move, which is about 1.08 meter per second. And that will be the same speed, like this is the speed at which 1.08 meter per second is the speed of the pellet and the speed of the wood, because they stick together and they're moving together, so they have the same speed. Determine whether the pellet is fired at a speed below a maximum legal. So how we work out, because we know the speed of the pellet here, which is same, and the mass of the pellet. So using this, we can work out first the momentum. And the total momentum before collision is equals to total momentum, like we'll use a conservation of momentum. So first, the momentum before collision, that is equals to mass of the pellet multiplied by speed at which the pellet is moving. So total momentum before collision, mass of the pellet is m1 and speed at which it is moving is u1. Mass of the wooden block is m2 and speed at which it is moving is u2. But initially the block is stationary, so its initial speed is 0. Then the final momentum, because they stick together, so it will be equal to m1 v1 plus m2 v2. But as they stick together, the v1 and v2 will be same as v. So I can say the final momentum will be m1 plus m2 into v. So using the conservation of the momentum, the total momentum before collision is equals to total momentum after the collision. So momentum before the collision, as the pellet is moving, the mass of the pellet multiplied by its velocity. So the mass at which the mass of the pellet, that is 0.93 gram. So 0.93 gram is there. We'll convert into kilogram divided by 1000. So it will be 0.93 exponent 3 multiplied by speed at which the pellet is moving, we don't know. Multiplied by the mass of the wooden block into speed, but because the wooden block is stationary, so its momentum is 0. Then after the collision, they stick together, so move together. So the whole block move together, and the mass of the total block, full block, is 150 gram, or we can say 0.15 kilogram, into speed at which it is moving, that is equal to 1.08 meter per second. When we simplify this, so u1 is equals to 0.15 into 1.08 divided by 0.93 into 10 to the power minus 3. This will give us 174.2 meter per second. So it is okay without even the system is not closed. Closed system means that object, like there is no external forces. So our assumption is always there that we assume that the system is closed. Then determine whether the interaction between the pellet and the block is elastic, and your answer should include a suitable calculation. So for elastic collision, the total kinetic energy before and kinetic energy after should be same. So the total kinetic energy before is only for pellet and after is for pellet, and because the total kinetic energy before collision should be equal to total kinetic energy after collision. As we use the conservation of momentum. So what we will do, like we'll find the kinetic energy before, which is half the mass of the pellet, which is 0.93 gram was there, so we'll convert it to kilogram. Into speed at which it is moving 174, and then v square, because half of this square. And kinetic energy after, it will be half the mass of the whole, which is the complete block and the pellet as they stick together, move together, which is 150 gram or 0.15 into speed at which it moved. So speed at which it was moving, that is equals to 1.08. That was the speed at which both moved together, and then 1.08 square. When we calculate the kinetic energy before and after will not come out same. So what it shows that the momentum is not conserved. Like momentum before collision is not equal to the, sorry, not momentum, the kinetic energy before collision is not equal to kinetic energy after. Like this will be 14 joules, and this is about 0.088. So the kinetic energy before is not equal to kinetic energy after. So means this collision is not an elastic collision. Momentum will be conserved, but the kinetic energy is not conserved. Another question in 1920s, Patrick Blackett investigated the interaction of alpha particle with different atomic nuclei. The diagram shows an alpha particle interacting with a stationary nitrogen nucleus. The alpha particle rebound off a nitrogen nucleus, the nitrogen nucleus recoiled in other direction. The direction of the path are shown in the diagram. The initial speed of the alpha particle is 1.2 exponent 7 and the speed of the alpha particle after interaction is 6.93 exponent 6. The mass of the alpha particle is 4 atomic mass unit or AMU and the mass of the nitrogen is 14 AM. Show that the speed of the nitrogen nucleus after the interaction was about 5.2 into 10 to the power 6 meter per second. So this is the momentum or conservation of momentum in 2 dimensions. And the same idea, the total momentum before collision is equals to total momentum after collision. But as the momentum, like because it is, there will be change in the direction. So for alpha particle, if I say speed of the alpha particle is, and after the interaction it was moving with 6.93. So this speed was 1.2 into 10 to the power 7. And this speed is 6.93 into 10 to the power 6. So this speed will have 2 components, horizontal and vertical, because it is making certain angle. So when we divide the component which is with an angle, that will be equal to 6.93. This will be equal to 6.93 into 10 to the power 6. Or I can substitute the values as well. So this will be equal to 6.93 into 10 to the power 6 cos 30 because it is with an angle. And the component which is against the angle, the vertical component, which that will be equal to 6.93 into 10 to the power 6, that is the speed sine 30. Same way, there will be a component for the nitrogen as well. One is with an angle, another one is against the angle. So speed of the nitrogen, if I say is V, so this will be equal to, like this speed at which the nitrogen move is V. This will be equal to V cos 10.9, which is with an angle, and against the angle will be V sine 10.9. Now we'll take a conservation of momentum in X direction. And we'll take a conservation of the momentum in Y direction. So conservation of momentum in X direction, the total momentum before collision is equal to total momentum after collision. So first, alpha particle is moving towards the stationary nitrogen. So it is moving towards the right hand side. So when we apply the conservation of momentum for the X direction, we are not converting the mass here. So the X direction, because this alpha particle is moving, so it is 4U, because the unit will cancel out, so we are not converting into U. So that is 4 atomic mass unit into the speed at which the alpha particle is moving towards the stationary nitrogen, that is 1.2 into 10 to the power 7. So equals to 1.2 into 10 to the power 7. This is the initial momentum before the collision plus the momentum of the nitrogen, that is 0. Why 0? Because the nitrogen is initially stationary. After the collision, the nitrogen moved towards the right hand side. So, and the alpha particle moved backward, recoil. So this one is because it changes the direction. So it will be equal to 6.93 into 10 to the power 6 multiplied by 6.93 into 10 to the power 6 cos 30. This one. But because it is in opposite direction, so we put negative sign. Why? Because the direction has changed. First, the alpha particle, the horizontal component of alpha particle was moving towards the right hand side, but it recoiled, so it is moving towards the left hand side. And plus the speed at which the horizontal speed at which the nitrogen nucleus recoiled or moved back. So that is equals to mass, which is 14, multiplied by speed at which it will move, that is equals to V cos 10 degree, because that's a horizontal, 10.9 degrees. So this is in conservation of momentum in x direction. And what about the conservation of momentum in y direction? As there is no component in the beginning, there is no particle moving in vertical plane. So the initial momentum or conservation of momentum, so initial momentum is 0, because both alpha particle and the nitrogen is stationary, where alpha particle is moving horizontally. This alpha particle is moving horizontally, so it does not have any vertical component. And then after momentum, this is a vertical component of the velocity. So mass of the alpha particle, which is 4 multiplied by speed, 6.93 into 10 to the power 6 sine 30. Why sine? Because the vertical component. And alpha particle and nitrogen nuclei move, vertical component is downward, so we'll put a negative sign here because they're in opposite. Like for nitrogen it is down, and for alpha particle vertical component is up, so they're in opposite direction. That's why we're putting a negative sign. So mass is 14, speed at which it travel or move we don't know, so that's why we call that as v. So mass is 14 and v sine 10.9 degrees. So when we simplify this will move other side, so it will be equal to minus 4 into 6.93 sine 30 equal to minus 14 v sine 10.9. This will go there in division, so it will be equal to minus 4 into 6.93 into 10 to the power 6. Here 10 to the power 6 to be there, and sine 30 divided by minus 14 sine 10.9 degrees. So this will give us the value of the speed at which this nitrogen will move, which will come out as 5.24 meter per second. So why I can use this equation as well, like I can use this one to solve y, or I can use a y1 as well to solve this question. We'll get the same answer, it won't make difference to the final answer. So either you can use a conservation of the momentum in x direction, or you can use a conservation of momentum in y direction. Why I prefer y direction? Because the total initial momentum was 0, so I was having few values. That's why it is easy to solve in this manner. But we can use both of them to work out the final answer. And then determine whether the interaction is elastic or inelastic. So what we have to do, we have to calculate the total momentum before collision, total kinetic energy before collision. Before collision is alpha particle, and after the collision it will be the kinetic energy of alpha particle plus the nitrogen. So before collision we'll get the kinetic energy of alpha particle which is half mv squared. So we are putting 4 atomic mass unit into the speed at which alpha particle was moving, 1.2 into 10 power 7. We are not converting atomic mass unit into kilograms, so it will give us 2.88 into 10 power 14 joules. That is the initial kinetic energy. The final kinetic energy is the kinetic energy of alpha particle and the nitrogen, the sum. So final kinetic energy, we'll find the kinetic energy of alpha particle, which is half 4u, and the speed at which it is moving 6.93 into 10 power 6 after collision. And kinetic energy of the nitrogen, it will be half 14u, and the speed at which the nitrogen is moving 5.24 into 10 power 6. So when we simplify, we'll get the total, like we'll sum them, we'll get the total kinetic energy. So if the total initial kinetic energy is equals to final kinetic energy, then we'll say it will approximately come out as 2.88 into 10 power 14. So if the initial kinetic energy is equals to total final kinetic energy, it means this collision is an elastic collision.